this is Jarvis Klein, and welcome to session number 3 of our mini project to develop a software utility that would be helpful for calculating mission parameters for aerial surveying. So, to have a look at where we left off last time, we had been working on setting up the ability for the user to define the instruments that would be on board the airplane so that the software can know what information to use to calculate the parameters, such as what resolution you'll get with that instrument when you fly at a certain height, and so forth. So now that we've allowed the user to define the instruments and then import and export them, we're pretty much ready to move on to the main part of the program where the user will do some calculations. So hopefully that will give you a better idea what this is all about. But I wanted to tidy up one thing before moving on to the main user interface. So actually, if we look at our to-do list, for the third session today, goal is mainly flesh out main user interface and perhaps start on some of the calculations. So this video might be a few hours long, and one thing I wanted to start with is automatically saving the list of instrument configurations that a user has defined. So the way it would be envisioned to work is that the user will define the list of instruments, and then when he closes the program and opens it back up, he'll have that same list of instruments, so most times he won't need to define it again. He does have the ability to import and export, but whatever is currently imported into the program should be saved to a configuration file that the program will automatically load on startup. So basically whatever the user does here will just automatically persist. Is one thing I wanted to set up. And the way that the program is working now is the main there's two places in the overall program that need access to the list of instrument configurations. There's this sub window or child window where the user defines the instruments, but then the main program as well is going to need access to the list of instruments. And right now, where that list is actually stored in memory is just as a member variable of the main form. But there's going to be some synchronization where, for example, if you add a new instrument type in this child form, that the parent form should maybe automatically update to reflect the change, because you'll see here some, maybe a combo box and other readouts about the list of instrument configurations. So because we have some synchronization between here and here, relying on keeping a list of instruments and well, what I'm planning to do is make what I will call a module for maintaining the list of instrument configurations, and then just both the child form and parent form will have access to the module, and they can, for example, basically register event handlers so that the module would generate events to notify every one of the changes. So that would be one way of structuring it. We may not actually make it that generic, but that would be kind of the idea nonetheless. So I'm going to go ahead and make a instrument configuration module, and I suppose I can put it here in the source tree. Where's our prefix here? So, to me, module is just kind of a term I'm using to say that it's something within the program that holds data and maybe also handles synchronization to multiple clients within the program that have registered to observe that data, for example. And basically, it's just a list of instruments. Guess we can create a member variable with that list, and we'll honor our constraint that that list is never null. Because of the way we're going to structure this, I'm going to go ahead and nominally make the list private so that you have to use some functions to, for example, add an instrument configuration. And, you know, whoever is listening and let's see. Maybe we don't have an add instrument configuration necessarily. Maybe we just have the ability to specify the current list. Because actually what I'm thinking of doing is one thing I haven't added yet on the user interface where the user can define the list of instruments is I need to add a way for the user to, for example, delete instruments as well as reorder them. So when it gets into things like, you know, I'll show you how I have in mind for the user to be able to change the sequence, but because the user may be doing those kinds of operations, it's possibly simpler to just make it work by refreshing the entire list of instruments. So maybe I don't have this function after all. Maybe what I have is refresh instrument configuration list, which I guess accepts an argument which is the list that should be used. Let's say arg copy instrument. So looking now into object lifecycle management, if I have this function where a caller can refresh the entire list of instruments currently in the program, what I think I'll do is I'll take that as a list, but then I'll just copy the list to a new list and possibly copy the objects inside as well, so that because this is a reference being provided by the caller, and if we just accepted this list directly, if we said our own private list equals the list that is provided in the argument, then the caller who had this list could possibly modify it further, which would be modifying our own list in a way that we probably don't want, because we want to make such modifications go through our basically our event handling subsystem. So we have to copy the list and probably also copy the members of the list. And you know, for this small project, that kind of thing might not be that relevant. I mean, you know, we may call this in a way where the caller who has this list is just going to throw the list away anyway. But still, we'll go ahead and structure it in the way that it should basically be structured. So let's go ahead and copy the list, and all I'm going to do really is let's clear our existing list, and for every item in the argument list, let's add a copy of it. And I believe we did actually write the copy function, so if you remember, we wrote this function actually not necessarily needing it at the time, but now we are going to use it, so it was useful to copy this object and return, you know, a new object with the same data inside. And so that's that. And then for the kind of event infrastructure where, you know, it's probably really only going to be modified by, well, I'll take it back, it's okay. What I'm thinking of is whether to make it kind of generic uh, or just to provide into it the actual classes that we know are going to want to listen to the update. I mean, I think what I'll do is not necessarily bother making, like, what we could do is have, maybe instrument configuration listener, and there's some function which says notify instrument configuration list updated, and then both our main form and our instrument configuration form could extend this interface, and here we could have a list of interface members here who have registered to receive this, and then when the update happens here, we loop over them and notify them. Oh, I guess we could do it that way. It's not too... I guess. 'Cause the other thing I could do is just and not do it in as generic of a way, but I guess I'll go ahead and do it this way. Maybe just to show how that might be done. In which case, this now is going to implement this interface. As well as what did we call it? And again here, guess just all the way at the bottom. I don't know. Not that. Where is it? And so then this module also has a list of people who are registered to receive the update event. List of listeners, I guess. Let's see, not null. And, one maybe benefit or not necessarily benefit, but one thing we get from using a list of listeners rather than just having an event that would fire, we could do this by having, for example, we could have a delegate, instrument list updated event using my own infrastructure here, but similar to a regular event, where you would just call this to update everyone who is listening for the update. But if we actually have a list of listeners, then one thing we can also do is say our optional source is that clear? Possibly we might have a situation where the source of the update might not need to be notified of the update, and in that case we can test for that here and not update if it's not needed, I suppose. So this would be one way of structuring this, and that's just kind of pros and cons, I guess, or comparing and contrasting whether using an event or a delegate, or just having our own interface, which is just kind of basically serving the same purpose. So I'll go ahead and use the list here. List of listeners. So and let's just say it's really let's say this. So this would be enough of a test, but let's see. Well, don't notify, for example, because this particular listener provided itself as the source of the event. Guess I'll handle the default case in the else statement otherwise. So this test is not needed, but is kind of illustrative. It just shows that this could be null, in which case we don't really need to do the test because the listener here should never be null. I mean, it would work anyway even if we don't have this clause, but I'm including this clause because it's kind of illustrative that we would only test if a given particular listener is the source of the event or doesn't want to be notified this time. If this particular argument is in fact not null. So, not needed but illustrative is this test here. And another comment about why I'm using object.reference equals instead of just arg. And I just prefer to say object.reference equals, although I might not always do it, but I prefer it if I'm doing a test by object reference because this could be, I think it could be overridden by a class, as well as if it's a value type versus a reference type. This is just being a little more clear about what exactly the comparison is, and I'm a proponent of being clear about what the operation is, even if it's a little more verbose. So that's all. But that's pretty much all I wanted to do there, I suppose. So let's see, where's our module going to reside? Probably just as a member variable of the main form. We just need it to be somewhere, and the main form can create it. That would be fine. So instead of having this now, we have our module. And I guess the main form can register itself for it. So I never did have an add listener, but I guess we'll go ahead and wrap that. We could make a version of this that adds it uniquely. so that you could potentially call this twice with the same object coming in, and we would only store it once. But no need to do that because we're only going to be adding ourselves one time per thing, as well as we don't really need to deregister ourselves either. If we were doing like a formal shutdown of everything, we could maybe have a remove listener. But we're a garbage collected language, and when things shut down, it's probably going to be the whole program shutting down. So we don't need to worry about that, I suppose. And we'll add ourselves as a listener. So I guess that's using a design pattern technically, but oh well. Then our form where we define the instruments, we are already receiving a reference to the parent form. We probably don't necessarily need this reference, but it doesn't really hurt to have it or keep it. And I'm just going to access the instrument configuration module from our reference to the parent form. So let's just say, and in fact, I can just say it's not really what I wanted here. It's the module. Oh well, it depends on the parent form being assigned. But anyway, our instrument configuration module is here. And this, form where we define the list of instruments, right now, it has a member variable that represents actually that list, and we're sort of freely adding to and reading from that list. Now that we want things to go through this module, so to speak, when someone wants to access the list of instruments, we have kind of an option. Well, why don't we do it like this? We'll make it a property, which gives us a little bit of let's see, readable, but color should not modify objects or list. So here we have a property that someone can call or read in order to get the list of instruments. And if we wanted to insulate ourselves from any potential bugs here, we could copy our private list and provide that to the caller. So we could say, for example, well, I don't actually have we could copy the list. It's basically, we would do what we did here of making a new list object, filling it with copies of all the objects that are contained in our private list, and then returning it. If we did such a thing, then someone who called this property to get the list of instruments would be like receiving their own list of the instruments and their values, and the caller could modify the list or change it, and we would be insulated from those changes in a way that we want it to be, because we want all such changes to come through our infrastructure here of a refresh instrument configuration list call. Uh, However, we would then have the overhead of every time someone wants to access or read the list of instruments from this central location, we would be copying the entire list and providing it to them. And I think what I prefer to do is avoid the copy of that list by returning the actual list. So they get the real list here, and if they were to modify it, it would be a program error. But to represent the fact that the people who access this list should not modify it in that way, I'm just going to be explicit about it in the name of this member. It's a property, but it's kind of a member variable. I'm just going to say uh, that whoever accesses this has read rights, but they should not modify it. They should consider it immutable, i.e., consider immutable. And this actually works because in another way, which is that we within the module are also not going to modify this. Actually, we do. We clear it. In order to make this a little nicer, where someone can read this and hold on to the reference if they want, but it should be read-only from that point, I'm going to, whenever we update the list, I'm going to update it by basically getting a new list object and filling the new list object. So what I have to do here is, so the total overhead is still going to be less. And, it's quite a simple example, so we don't necessarily need to be paying this much attention to the subtleties here. I mean, we're looking at it in a way that would almost be suitable for like multi-threading or something, which is not anything we're doing here. But nonetheless, what we just accomplished or have set up is that within the module, which is the central location for the instrument configuration list, we have a private object which is that list of instrument configurations. We allow callers to access that private list, but we specify, and kind of it's a contract here in the function, in the property name, that whoever accesses it should consider all the data immutable, both the list and the contents of the objects within the list should be considered immutable, even though they technically aren't, but we just have to enforce that contract by discipline of, art of the programmer and the people who review the code and see that this is how it's supposed to be used. So this is now immutable, but in order to honor that, it means that even within the module, we can't modify this list after we have given it out to someone. So what that means is there's one central location where the list is modified or updated, which is this function here, and instead of modifying an existing list by reference to that list, we update ourselves by creating a new object, which is a list, creating a new list and populating it. So anyone who had a reference to the previous list will still have that reference valid. I mean, this is all a little bit beside the point because the way that things are going to flow through the program is people are going to read this list, do what they need to do it, and then throw it away. So it wouldn't actually matter if we then update it, but just as a way of showing a nice way, kind of a rigorous way to structure this whole thing, I'm going ahead and doing it in this way. And now, because I want to make sure that the design, constraints that we are contemplating here, because I want to make sure these design complaints are actually constraints are actually followed, I'm going to just make those constraints, those design decisions, explicit in the names of the variables involved. So we did that here by saying this instrument list is accessible, but it should be immutable. And that's just a light wrapper around the actual private list. I mean, we could add all of this information into this itself and let the caller just access that, but it's good to have this property. The overhead is still light. We're not duplicating the entire list. Not that there would be much overhead anyway, but just to show a good way of structuring the whole thing. And but what I was saying is that to make sure the design constraints and design decisions are very clear and express and followed in a way that can be reviewed. A code review can be done to make sure the constraints are followed. I'm going to add another tag here that says modified by reassignment. Modified by reassignment only. So this is a bit idiomatic, but what a tag like this means to me is that we maintain this object which represents our list of instrument configurations. What it means is that once you populate a list with instrument configuration objects, you can never modify that exact list. If you want to change the list that is used, within the program, you have to allocate a new list because someone might be retaining a reference to this list. It's sort of like we were designing it in a way that would be appropriate if we were multi-threading things, even though we aren't. But what this just says is you can, construct this one time, but you need to assign it a fully formed. I mean, that's actually a better way of going a little bit deeper here. You need to fully form the list and then assign it to this reference, which refers to a list. And otherwise, you can never modify the list except by assignment of a completely new, well-formed list. So to see how we're going to do that, instead of even doing this here, because this would be a blank list that we then populate, what I'm going to do is new list, populate our new list. Sorry. And then once the list is fully populated, we assign it to our main central list here that people will read from. But we do this assignment in a way that is atomic. So this is just a nice way to structure things. For example, if it were multi-threaded or something, even though in our particular case we aren't. Alright, so now going back to one up our stack here of what we're doing, back to the form where the user defines the list of instruments. We want access to the list of instruments, and we can directly get it from our instrument module. We'll just say readable, but I guess I'll maintain this constraint here in the name of this. Readable, but callers should not modify objects or list, i.e. consider immutable. Why not? And this is just the it's just that. And we can actually still have a set function here on this list. Well, that would be a little conflicting with our naming structure, because we'd have like one set of constraints for when you're reading it, and the constraint wouldn't apply when you go to set it. So it's a little awkward to have both a getter and setter here, but what I can do is set or update instrument configuration list, and we'll refer to our module, and we will refresh the list, and with the value that's coming in here. And optionally, we could refer to ourselves here to say we don't need to receive the update because perhaps we are the source of the update and we've already handled it. So we'll see. But let's see. I want to go just have a look at this function again. Why don't I go ahead and handle the case that someone could pass a null list here, and we would just gracefully handle that by considering it an empty list. So let's say now what we'll get in our new list here is just an empty list. If this was either empty or null, it's just kind of being a bit defensive, I guess, which is fine. And then I need to see, you know, I've changed, I made a breaking change when I renamed this, and when I removed the setter function, but now I have this as a substitute for the setter function. So I'll just compile to find where I need to make changes. Oh, you know, I'm somewhat at odds sometimes to the design decisions of C#, where when you implement a interface, you don't expressly, there's no indication that you are expressly implementing the interface unless you use explicit interface implementation, in which case you can't access the function unless you cast it to the interface first. This is just subtleties of C#, which I personally think are annoying, but so here we had an assignment when we imported our instrument configuration. So instead of doing that assignment, we'll call our function, which is this guy. And see, for example, here we are already handling the update ourselves. So, but you know, let's go ahead and I guess we can copy this so that if we ever need to handle an update that maybe is generated by the main program, which probably won't happen, but if we were to handle such a thing, I guess this is what we would do. And then we can probably, you know, where we just were, I guess we can call that same function. So, you know, when we do this, we could either put null here and not have this, and then the module would call this function, or we put ourselves here and then call this ourselves. So either way, was there anywhere else that needs to update? Yeah, probably going to use our instrument configuration a number of places. Because I've structured it as a property now, even though my access to that property is efficient, I'm going to access it only once. So see, I have the list here and here. I'm going to make a local variable to get the copy of that list or reference to it, but it would be a little more efficient even if we were having a property that generated a complete copy of the list. And I'll save that list here, instrument configuration list. So now I refer to the local copy. And refer to it here as well. to this list once, so no need to make a local copy. It's just this guy. And alright. I mean, another thing I could do in this function, I could make it so that a parameter that gets passed in this function would be the current list of instrument configurations. But I'm just going to let whoever wants such a list to have a reference to the module and access it themselves directly. So I could optionally, I could provide the list here in the update, but I won't bother. Here we have kind of a set operation, so what we need to do to structure that now, so where are we anyway? Okay, apply edits, that makes sense, but I'll make a copy of my list. I guess what I'm saying, if I want to follow my workflow here, I guess I have one more. Whoops, what just happened? One more property of our instrument configuration module. Instrument list, create copy new list with copied objects. What can I say? For caller, i.e. caller owns obtained list. So that's wordy, but that's sort of the idea here. And this is, for convenience, but it's because sometimes you want to get a copy of the list, and then you want to modify it so that you can set it back here. So what we'll do here is where are we? Guess I could get a local copy of this. My goodness. I made a local copy just because that's how I would do things if I were actually multi-threading, which I'm not, but oh well. Let's see. And I'm sure there are, fancier ways you could implement a copy, the way I could copy a list. If the objects within the list had some kind of copy, if they implemented some kind of copyable interface, then we could have a single function, generic function that would make a copy of a list and copy all the things inside it, because it would know how to copy the things inside it. But I don't think it's that big a deal to just copy a list kind of manually when and if you need to. So that's what I did. So now, in this particular instance where we want to get a list of instruments and then modify it, you can say local working. Module instrument list, create new list, blah 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 blah, with copied objects for caller, i.e. caller owns obtained list. Then we'll take this one and modify it. Then after modifying it, we will go back to our module and update it. Not that one. Is it? This is maybe not a best name. Let's see. Guess we can say that we ourselves. Well, we have a property that does the same thing, don't we? We have a set list, right? And as I was looking at that function name, I didn't think it was the best. Maybe I'll just call it update or refresh. As you could pass it something that is exactly the same list, and it would still go through and notify everyone as if it had changed, even though it really hadn't. But it's just called updated, not necessarily changed. So let's see. Do we compile now? So, I had a file that had some instruments in it. Here we are. And, you know, we can add a new one. And I suppose if we close this window and open it again, we get our list here. So, alright. I'm going to implement it so that you can't have two copies of this window open, but right now it does allow you to have two copies of it open. Do we ever add ourselves as a listener? One second. I'm doing this really just, I mean, if we have it on form closed, then maybe we should remove ourselves as a listener so we can go out of reference. But I'm only going to allow really one. Or is that true? Okay, I guess I'll handle on close, and I'll add the ability to remove listeners. 1 second. Where are we? Module. I suppose there's enough activity happening in the module, it should have its own source file. Of course it does, I just forgot that for a moment. There it is. And remove or no op. Do we have... I guess it would logically be a remove all. You know, why don't we just do it ourselves? I don't really trust. I don't trust the functions from the .NET framework to not throw exceptions needlessly. Like, that was just an example. If you have remove all, I don't need that to throw, oh, a predicate and the match, and yeah, I don't know, it's generic or something, so I don't care. Maybe because the list doesn't know in general whether it has value types or reference types. Anyway, I'm just gonna, maybe we have a function to do that. Remove all occurrences from our list of listeners. And here's the arg listener. And I said remove listener or no op because if for some reason you called this twice or you called it with someone who didn't already exist in the list, it would just gracefully handle that case, quiescently handle the case that we don't actually find this in the list if it had already been removed or something. But of course everything should stay pretty synchronized, lockstep in sync. So we'll add ourselves when our form is created, and we'll remove ourselves when our form is closed. There's two versions of, where is it, on close. There's, I guess, on closing, and then there's another one on form closing. And these are pretty much the same thing, just in the .NET framework history thereof, it ended up having the same thing twice. So we'll pick whichever one we want. I mean, look at this. Even that's repeated. But oh well. We'll just say if we're closing, go ahead and remove ourselves. And that just is going to allow, sorry, what? If we're closing, just remove ourselves. That's just going to allow the form to go completely out of scope and be garbage collected if we close the form, for example. And then the other thing I want to do is add ourselves as a listener, which we do here. And none of these are properties, so that's okay. So in the end, I'm not going to allow you to open this window twice, but, well, heck, maybe it wouldn't hurt to allow you to open it twice, because if you just say, I'm going to import something, then we get it in both lists. If I make a new instrument, what's going to happen? Hey, there we go. So that's neat. I wasn't planning to, but maybe I will let the user open the window twice if he wants to, because they'll stay synchronized. And maybe he wants, like, to open one window to look at the parameters of something while he's, like, making a new instrument in the other window. So you never know, so I guess that's okay. Why not? And where were we? Oh, one thing I want to show, because we kind of designed it to have this capability, so let's go ahead and use it, which is that the user can delete and reorder items from this list. So I'm going to implement that as the user will be able to delete and reorder directly from interacting with this list view. So maybe delete is the simplest one, and we can do that right away by just implementing a menu. But I tell you what, I want to do copy and paste. So I have implemented something in my custom list view class, which is basically cut and paste reordering. So in our initialize controls function, let's look at our list view, cut and paste, menu. So I thought I had something that you can just enable it on the list view, cut and paste reordering, and then we need to handle it as like an event, register ourselves to listen to when the user does reorder it. But let's see. I mean, so here's kind of the logic of how that works. But where do we add it as a menu item? Or do we? I guess we never did. There's a copy, right? Or how does it work? Cut and paste items, which just takes the selected set of items. Well, I want to go see where in my code base we used this before. As it looks like there was more done on the usage side than on the library side than I had realized. So now I am opening up a special project that basically has my entire code base within it, and I don't work in this project because I prefer to have my code base split over multiple projects, so it's a little more manageable to actually, you know, flip through and work in. But if I just want to, for example, find out something is used, I can have my entire code base in one project in order to do that. And what we're looking for is maybe just by that function name. Do I have that open twice? Okay, here it is, cut and paste items. Where do we use this? This could be from the project. Well, really, we only used... Uh-huh. We're not finding it because... Here, this will find it. Because I actually have several versions of the project that has all of my source code in it. What just happened? Not what I wanted to paste. Stop, stop, stop. My goodness. That was a lot of things found. So when we use it, what we're doing is we have a menu command. We have a copy, right? Let's see. We're storing that as a member variable. Okay, so it looks like when I had implemented this before, oh, VB, terrible. Right, I'm not even going to look at that, but it looks like when we implemented this behavior before, and I just couldn't remember, we had done a fair amount of handling on the caller side or usage side, and I want to add basically the more of the capability into the menu itself. So, I mean, into the object itself, but the list view is gonna have additional menu items. How are we gonna do this? I mean, I guess one way I could do it is so the user can copy selected items and the user can paste above, paste, copy, paste previously copied items above, and he can paste the previously copied items below. And we need a way to add this to our menu. So, for example, we say, you know, enable cut and paste items menu. And what we would have is some type of menu for ourselves. We would say, let's do this. Cut and paste reordering, I guess. And we have copy items. And maybe we can have a separator. Or maybe what we'll do is we'll have a push paste items. have paste above wherever the user clicks, and we'll have paste below. I don't know. So this is going to go to this menu command. And this is going to go to this menu command above and below. And then we would have something like the menu gets assigned. Whoops, it's not this menu, it's just the menu. So we could do this and set that up. The problem with this is when someone is using this list view class, they're going to be adding their own menu items, and we need to integrate, these kind of prepackaged or menu items that we're providing in the library itself, but we need to be able to integrate them into the list that the caller is going to set up, that's going to be set up where this list view is used. So I think what we'll do is just accept this as an argument. Menu. Too much, too much. What is going on here? Oh my goodness, that could have been terrible. Definitely, I want to do this on the selection. On the selection, menu with arg menu. Alright. Anyway. Right. And, so I'm using kind of my own wrapper for setting up a menu on a WinForms user interface control, and it's just called a context menu builder, and I use it pretty much all the time that I am setting up a menu on a .NET WinForms control. So I'll go ahead and just use that here. I'll expect the caller, if he wants the list view to have the cut and paste reordering option in the list view, then he needs to provide the menu builder that the caller is using himself to set up the overall menu for the list view. And then what we need to do is what does this return? List view item collection. Can't I just get a regular list? Because when I go to cut and paste, it's going to want it as an array, it looks like. And okay. So what we'll do is just store, I guess, an array of C list view items, private copied item list or null, for example, and then we need to populate it. Do I have anything? Really? Selected list view items. Yeah, that looks like the property I want. And let's have a look at what this does. Just loops over all the items, and if it is selected, oh no, it gets the selected items and loops over that. Oh well. I wanted it to come in as an array, and I'm getting it as an array. Then, if the user's going to paste, then, I mean, this is a user interface. Normally I would be a little reticent about showing a message box to the user, but we are currently programming on a list view, which is a user interface element, so it should be okay to just pop up a message box here which says there, please copy, copy one or more items first. I mean, something like that, which will be here as well. These will be mostly the same function. Let's see. Then, if it's not null, then it'll be populated, presumably. I guess here it could be empty. Let's see, if it's empty, what do we want to do? I guess we could say no items copied because nothing selected. In which case, we'll just set this right back to null. So if it's not null, it has something in it, and we can call our cut and paste items function. So what I want to get is the insert position is our selected index position. Currently selected index. That's clear. This is one of our own properties, which oh well, I really don't care what's going on under the hood there. So the insert position is that, and we said that we're gonna paste above, so it looks like the enum for that comes here. If it's -1, insert, if the user doesn't have anything selected and he clicks to insert, he's probably appending them at the end, I assume. So let's just say that if the insert position is -1 because he doesn't have anything selected, that means the insert position is right at the end. Whoops. And we can go ahead and call with our insert position, and in this case we paste it above where the user clicked. Otherwise, we paste it below where he clicked. Yeah, and does the function accept it if you pass it in as count, or do I need to instead pass it in as the last object? Adjusted position. Well, it seems to accept it even if it's at the end. I don't know, I'll just try it and see if it works rather than look at this too closely. And let's see. So that compiled. Let's go back to our program. What are we doing here? Now where we initialize our menus, I guess logically it would be here. Context menu builder, list view menu. List view. I guess we can make it the first thing, so the list view enable cut and paste items menu. There's one more thing we're going to need, which is a handler for when the user does that. But let's just go ahead here and say the other thing we'll add to the menu is delete. And I'm putting the delete command within a submenu. I just wrap it one level so that it's not so easy to click accidentally. And I'll do that instead of adding a confirmation, are you sure you want to delete? You know, instrument, configuration, list view. So what the heck? Oh, I guess I'll come back to that. I want to just see if our cut and paste reordering is working. I'm not handling it correctly yet, but let's just see if we can move items around. So let's get our list, and if I copy this camera item and paste it below the push broom, then the camera came below the push broom. So did you see that? Well, we can also do some kind of invalid things here. So if I copy these two and paste them at the end, for example. Oh, so that didn't work. Yeah, I guess it needs... Oh, well, I could have done that. Or no, never mind. Probably what I should do is really just have another thing here. Let's just do it here. How's that? So we get our list. I copy these. I paste them down here. And this is totally not... Oh, well, that was interesting. Guess we refreshed the list right away. But anyway, so the user can move things around, and now I want to just handle that correctly when he does so. So we need an event, or basically, for when the user does that menu command. And all I want to do really is say, you know, I made that private, but it's logically private, but I just don't really use access control. I make everything public. Just what I do. This is, what do we call our listeners? User cut and pasted list view items event. And this can just be... I'm just going to make this... if someone wants to handle this event, so to speak, they just provide a function that accepts no arguments. They should themselves know what list view you were talking about, and they can look at the list view to see what the items are now if they want. So in my own kind of infrastructure here, that's just a notify delegate, so to speak. And I'll construct that in our constructor. since I usually put initialization in a constructor, you could actually have said, I could have done that here, but conceptually I just think that's a little messy, so I prefer to put them in the constructor, basically. But then what I'll do is handler. So if someone wants to register for that, they can optionally do so. Is that gonna work? Yep, that's what it wanted. I think that would work. So what we have here, I don't know, I feel like I want to back up my source code randomly. That's what I feel like I want to do. Maybe I'll just back up my entire source code, why not? Where's my temp folder I've been using? Oh, it's in here, huh? Anyway. Whoa! Oh, it's zip files that are... So that was a little unnecessary, but oh well. Source backup number 4, basically. And where are we? When we enable cut and paste reordering in our initialize menus command or function, here we are. If I say null, it doesn't blow up, right? I just want to make sure. You can leave it null. Otherwise, we'll have a handler here, which is user performed cut and paste instrument configuration reordering. So we'll handle it when the user reorders the items, and I think what I'll do is when he does that, we will gather up the instruments in a new list according to the sequence he has arranged them. So let's iterate over the item list. Item number, items, what? Isn't there some property that gives me the items typed? It would be nice if they were typed. Maybe not. Anyway, it's a generic list. Oh, maybe it's that one. Yeah, why don't I do this? So this is just kind of convenience. What I could be doing is every time I access the item from the list, from that list view, I cast it to the item type that it is. So that wouldn't be that big a deal and would be a little more efficient because I want to look at the inner object, which is the instrument object here. So this would be a little more efficient way to do it, but then you're doing a cast and you know, it's a generic list, so we should be able to get the list of items in terms of uh, that, you know, the item type that it's using. So that's what I'm going to go ahead and do. So we have our list view items. Let's say item I equals list view items I. If, let's see, what is it? Yeah, this is wrong, I'm sorry. No, that should be right. There we are. If it's null, don't do anything. Otherwise, build up our new list in the order that the user has to find them. And, whoops. And then update. So, what is it? And actually, in this case, everywhere else that I'm calling this, I am manually calling this. Maybe I should just let the notification infrastructure notify us that the update has happened, but oh well. And, you know, tell you what. This is a bit silly, but refresh ourselves. What? Refresh ourselves. No. We'll refresh ourselves separately. Refresh user interface option. Oh. Terrible, terrible. So that's basically that. And then where we call this, in this case, go ahead and refresh ourselves as well. Because the user has reordered things on the user interface here, but he may have done so in a way that was somewhat invalid, such as the new instrument configuration might not be at the bottom anymore. So we want to do a full refresh, and everywhere else instruments used. Here we can say no because we're doing it ourselves right here. And here we can say no because we're doing it ourselves. Even though, you know, that could be revised, but why don't we implement the delete functionality while we are at it? Where was our delete? So what we want to do is, I guess what we could do is the following. Figure out what these are as selected. Or I tell you what. Well, let's get this whole thing. We'll go through each item in the list. That's funny. If he tries to delete the new, maybe we could just clear it? Alright, we'll do special handling for the new. Alright, if he's... Here it is. If the item I is selected, so the user is trying to delete this instrument configuration. So don't gather it up in the total list of instrument configurations. Otherwise, the user is trying to delete the new instrument placeholder. I guess we could just quietly clear it. So that'll clear all the settings on that. Otherwise, all we're doing here, the user selected some stuff to delete it. What we're going to do is loop over all the items in the list view, find the ones that are not selected, gather them up as the new list, and provide that as the new list to our instrument configuration module. And here we're doing an update that affects the other fields. So let me see. Yeah, this is refreshing everything, so that'll work. So let's go have a look at how that might work, assuming it builds correctly. And why not? I'll open up two windows. I'll import my instruments. I'll delete something. Come on. Maybe it doesn't work if I try to do that within. Is it because do I need to just refresh it or something? What happens when I delete this? update everything. Oh, wait. Yeah, I guess I just got something backwards, didn't I? Yeah, I got something backwards because this is optionally providing if we want to refresh ourselves, provide null to the underlying update mechanism so that it doesn't know to exclude us. Otherwise, if we are not refreshing ourselves, then we provide ourselves so that it knows to exclude us. So I can now delete and delete. And if I enter in a new instrument that has some stuff here, but then I orneryly, in an ornery way, I go and delete myself, it just clears the new one but doesn't actually delete it. If I highlight everything and delete, I'm just left with that. And how about cut and paste reordering? So I guess this should be cut. I should have called it cut. This should do nothing at all. So that wasn't good. Let's make sure this gets called. It did not get called. So did I forget to invoke it? Probably I forgot to invoke that event. So when the user actually does it, we evoke the event. Invoke and invoke. Alright. So copy these, paste them above, for example. I don't know what I'm doing. Let's see. Copy these, paste them here. This should have no effect. Oh, I also never cleared, but I probably should. Oh my goodness. So I want to call it cut. It's cut really. And then if the user does it, I want to set the list that has been copied to nothing. This is cut. But that doesn't actually fix the other thing that we saw there. What was that? Why would they have come twice? I don't know, let's see. got the camera and the push broom, and I cut these, and I paste them down here. I mean, I selected the laser and the push broom, right? Yeah, so that worked. And if I paste again, is this an exception? Where are we? Why did we jump into here? Is there a breakpoint? Oh. Remove items if present, and it's null. So don't call it if it's null. Oh, I didn't break out. Ah. Another programming mistake. An embarrassing one. So if these are pastes, so there we are. That I assume will fix some of what we had going on. And it's kind of neat. Cut and paste reordering on our list of instruments. So I say, oh, I really wanted to move this laser scanner down one. Cut it. For the camera, let's say it comes after the camera. There. And I prefer this to another thing people sometimes do is just have a move up and down button. So you highlight one and you move it up or down. I'm not a big fan of those because I don't think they scale all that well. If you have a large list, it's just kind of more general to be able to select what you want, a group of things, cut them out, and paste them back in wherever you want. I don't know. Let's see. Then if the user really wants to get aggressive, he can just export the file, come in here and manually edit it. What do you think of that? He can reorder them here if he wants. Anyway. So with that working, I think what I want to do next is set it up so that when the program first runs, we are going to load the kind of default configuration file. And probably anytime we apply any change at all, we are going to write to that configuration file so that the changes are just automatically, or by default they are persistent changes that the user does. So why don't we go ahead and do that. Does look like our session today is yet again dealing with instrument configurations, but that's alright. Let's see. I guess just from within the logic of the main form, I'll have default instrument configuration file path. And let's get a path to our own executable. So here I need to take a little detour to talk about executable path. Maybe I'll just get this one. The base path says just the path to our own executable without the exe extension, pretty sure. But I'm going to be saving the default instrument configuration file in the directory that the program is executing from. That's kind of not the recommended way to do things on the Windows platform anymore, because programs get installed by default into the program files directory, and they discourage you from making modifications to the program folder. For example, by setting the default permissions and everything inside here to not be writable, and they do that kind of to prevent, as a security measure, to prevent your programs from being modified by malware or something like that. But I'm gonna go ahead and do it the kind of old school way of just saving the file within the program executable folder, because the alternatives to that I don't particularly like, because they the alternatives just involve the program hiding it in places that the user is really not likely to find it. It's either going to be hiding it in the application data folder of the user's user profile, Windows user profile, or it's going to be saving it in the registry. And I just think it's more obscure, so I don't like the direction that's taken, even though to do anything else is kind of old school method. But what I'm doing is also still legitimate in terms of it being a style useful for a so-called portable executable, which is what most of my programs are. I usually make programs that don't need to be installed per se, other than making sure the prerequisites, such as the C++ runtime libraries and the C# .NET framework rather, is installed on the computer. And other than that, the program as such doesn't need to be installed. So I like the kind of portable executable approach. And so as a portable executable, it would be quite legitimate to have our configuration file in the program folder. And so we just let the user know about that, for example. And in fact, we may put up a status if it happens that our program gets installed in the program files folder where we don't have write permissions. I'll probably just put a status message and explain to the user, hey, we couldn't, we don't have write permission or something. So instrument configuration file path equals our base path, just tweaked a bit by suffixing it to say instrument list maybe, and by changing the extension to XML. But I suppose I've used this XML extension in a few places now, that I should really put it in a central location, so that if the extension were ever changed, it could be done centrally. So here in a file that sort of represents our instrument configuration list or file, therefore I'm going to have so where do I use that? I use it here. Where's our list util? I need to make it, what, public? Static? So there's that one, and here's the other case. Back to where we were in the main form. guess I'll just do it like that. So now when the program loads, let's go ahead and load from our default file. So we're just going to perform a load. And then I guess what I'll do for the moment is just not have any error handling really, but just try to load it, and if we load something, then we will set it. Otherwise we'll just not have anything loaded. But let's see. Then every time the user makes an edit, I guess what that would be, I guess we could, I'll have this handled by the, so I tell you what, I guess it would be better to have the logic of loading and writing to the default instrument configuration file. I guess it would be better to have that logic handled within the module. So we have this module here, and the reason I say that is every time we update it, we could just write to file, but we wouldn't necessarily want to write to file if we just loaded from the file, if that makes sense. So let's see. Load default instrument configuration file. And here's just some stuff. I guess this will now exist in the module, and when we load it, we want to have this logic, but not save it, I guess. Probably not save it. So maybe there's one more one moment. Private version of this function has one more parameter. Update instrument list. Save updated list to default file. I guess what I should just say, yes and no. So if after getting our new list, if yes, write it out, and here we could keep the function the function signature we had previously and just let it wrap into the new function version we just made. And by default, yes, we will save. For error handling and such, but in this case we maybe don't need to because we just loaded from there. For error handling, we maybe want, every time the user performs an update, maybe we want to return a result that indicates whether there was a problem writing to file, for example. So I guess that would be okay. Let's see. Return result of whether of file operation. So let's go ahead and write it out actually while we're here. If we are going to write it out, then we have our list util, save or write, given the list, which is our new list, and the path rather is default configuration file path, and our list. This will return a result. And maybe we'll just do this. Otherwise, by default, it's a success. If we're not even going to write it out, we can just consider it a success, an idempotent success. Or default success, I guess, is what it would be. Or default success, har har. And then, in the usual case, where a user, I guess we won't care at this particular, when we call this function, maybe we don't care if there was a problem, or maybe we do, I don't know. But anytime we, well, right, we're not going to try to save it, so this will be the default success. So this wouldn't have an error saving it, although it might have an error loading it. But anytime we update, we do a regular update to the instrument configuration list, we're gonna get a save result, and I guess we'll just return that to the user, to the caller. Return error if error updating to disk default file, something like that. So then, so just when the user makes a regular update, we say he should save it. If we want to notify the user if a problem ever happens, let's see if we compile. Oh well, we probably don't, do we? So where are we? Changed our name. We'll just do nothing with it for now, but it should compile with a warning, this is useless. Let's go to our designer. So it compiles, but we still can't access the designer. So let's see if a restart will fix it. Hopefully it does. Otherwise I wouldn't know what to do. But we're back. And I think what I will add on here is just a little label. Some kind of status label. Would sort of be worth having a label class specifically for a little status message that maybe disappears after a short time, but I don't think I have a class to do that. That's alright. Warning, could not write to default configuration file. Label, readout, write default configuration file warning. Or really, all this could be used for multiple prompts. Status prompt. And this is an example status prompt. And we will clear that as soon as we load up. And let's just have a function that says so we say label readout. And I want it to just appear for maybe 5 seconds or something. We could also put a timestamp on it. We'll add timestamp prefix so the caller knows he probably shouldn't have a timestamp. Local timestamp, just the hour and seconds, I guess. Maybe a tab after that. I want it to clear after maybe 5 seconds, so how can I do that? Clear status prompt tick. I mean, guess I'll have a timer here. Public private, let's see. If there were, you know, if this were called twice in succession, we would want to reset the timer. So if a previous timer exists, just turn it off. Make our new timer. And set the interval for 5,000 milliseconds. Add our handler. And enable it. And then once that fires, we just say the label text is clear. So how's that? So every time we do this update, if there were a problem, we say let's use that text. How's that? So we'll need to test it. I think what I'll do is add one just for testing the status prompting every time we update the instrument configuration list. Yes, yeah, I'll just add it here. Updated, just to see if it's working. That's okay. That's maybe not okay. Oh, right. Take n here, and this is what file? It's our own file. That's okay. So, if we import some stuff, we should see our little message. The tab didn't seem to work very well. Well, right. I should maybe do this. Okay, well, 5 seconds is pretty short, so maybe I'll make it 10 seconds. Where's our prompt? And the tab didn't really work very much, so I'll just do that. And hey, look at that. We persisted our instrument configuration. So that's neat. Let's go back to what we were. I need to anchor it, and why don't I just do that before I forget? Our form needs to be a little bigger, and we need this to anchor. It's kind of annoying. Let's see. Just turn it off while I resize the form. Oh, come on. I turned you off. That's stupid. Why are you so dumb? All I wanted was to temporarily unanchor these. Expand this a little bit. anchor them again. But I don't actually know why we don't see it. Are we programmatically adjusting the height anywhere? I don't need that anymore, do I? Do I? Whoops. So, we updated our list at that time. Disappears after a while. If we... guess the quickest way to modify is just to delete something. 1643, 1647, and it still stays around another 10 seconds, so looks like that's working. I don't really need that particular prompt. Where were we? To test this one, maybe I will actually test it properly. So our executable program should be here as it runs in the debugger. Here's our instrument list file. If I just make that not writable, oh jeez. Everyone can read, but not write. Where's write? Everyone can read, but not write. Then we should see that as an error message. Yeah, the access is denied, which throws an exception, but I'm wrapping that in my own handler that converts that to just an error because I see no reason to throw an exception just because you couldn't open a file. So I wrap it as just returning a failure result, so I can just continue. And I get the warning, could not write to default configuration file. And apply something. Oh, I'm not updating these kinds of edits. So that's the next thing I should do, is update these kinds of edits. Why don't I do that now while I'm thinking about it? So where are we? Where are we? I do have one function that everything flows through when we do that, because we're already refreshing the apply and revert changes edit box. Oh, well, right. It's when I apply it that I want to do the update. So where's my apply? So what is this? If it's the new configuration or otherwise, I guess either way, we want to do an update. So we just say guess we already are calling it here. Let me have a look here. Yeah, I guess just call this here, right? Why do I have... Oh, sorry. There we are. I can let it refresh us, I guess. Or we don't need to. Alright, I guess that's all I need to do. So it's just saying, I mean, we don't really have a... within our instrument configuration module, the only kind of update we understand is a full update here. And we just had a use case where we sort of just are updating an object within the list, within the instrument configuration list, and that could be maybe a separate function that maybe doesn't have to go through what we're doing, which is you know, making a full copy of the entire list, operating on the entire list to do the update. But that's okay. We'll just read the entire list here, and then update the entire list with the original entire list, but it's going to copy it. So it's kind of going through a runaround, but that's just the way we have of saying that we are doing an update. And that's okay. So now, if I apply an update, this sort of doesn't look right, does it? Because we haven't edited anything? Is that the way it was always working? Well, anyway, could not write to default configuration file, but then once I set the permissions back to normal, we should be okay. But was it always the case that, yeah, why is this allowing me to edit when I haven't actually made an edit? Let's see. I've gotta go track that down now. Maybe I'll just exit the debugger for a moment. So the logic behind enabling those buttons is refresh farm here. So here's the logic for whether he has made an edit. And if he's on the new one, which he shouldn't have been in that case I was looking at, so let me look here. We get this one, we get that one, and we check if they are the same. So my error should maybe be in this comparison. Let's see. Yeah, I have an error here. So actually, I never did step through this and make sure things check out roughly correctly. So let me just have a look. Let's see. So just when I highlight this, you know, the other one within that statement should highlight, and probably nothing else. This one should get that one, this one should get that one, this one should get that one, this one should get that one. Each of these is just used. Let's see, that one and that one, this one and that one, this one and that one. Alright. Guess that should take care of that. And we import our default list. Sort of flashing at us. If you can see it in the video, it's flashing at us that enabling them for a moment, but that's alright, I guess. So that's pretty neat, because now as we modify these, so if I say 24, if I move away and come back I should lose it, but if I apply it, then even if I close the program, push 24, it's 24. So I think we have managed to spend, you know, most of this particular video just setting up, finally nailing down the instrument configurations, how you edit them, how they synchronize across the program in the various places they are referred to, and how we write them out to a default file that automatically gets loaded when the program gets loaded. And having spent as much time on that as we did, I think I'm going to save, moving on to the next step for the next session. So from the next session, hopefully we can directly start into actually making the main user interface here and getting that to do what we want it to do. So with that, thanks, and be back next time.